Welcome to the HeaterTreater video, and we're featuring the core regulator product on this video. What you're looking at is a Chevrolet SSR, and you're just looking at the reservoir tank. We're going to go ahead and put the core regulator in line with the heater core. The idea being to have the capability to shut that heater core off and improve AC efficiency. This is an SSR. This same process can be used on any automobile, and you need to kind of look at the process and what we're doing. And of course, it's going to be different on different models, but the same basic philosophy will be the same. And once we do that, this whole module will kind of lift out. We're going to leave the main hose connected to it and just kind of lay this back up out of the way in order to get access to the heater hoses. With the reservoir tank removed, you can now see the heater hoses and see how they bend and go up before they go into the firewall. We're going to make a cut just above that 90-degree bend, and I'm showing that here, and we will install the core regulator valve in this area. Here's the core regulator in place and the two bottom hoses connected into it. It is important to get the right hose on the input, and it will be clear in the instructions that come with the kit, but one of them has to have the water flow coming from the water pump and the other is the return, and it is important that you get the right ones. Here's a picture of the system with the top cowl over the center of the engine removed, and you can see how the two heater hoses come up and go into the firewall. Now, the installation we did further down the line from this point, but there's really no reason that you couldn't do the installation right at this same point next to the firewall. You need to be sure it doesn't impinge on the cowl covering, but I think there's plenty of room and maybe minor modifications to the cowl, and you'd be able to get it working correctly, placed up closer to the firewall. Once we've got the valve in place, the next key is to get the electrical wiring done, and we do need to ground the black wire coming from the kit, and you need to make sure you get a metal ground, not a plastic ground. Sorry, I learned that from experience. So we'll get the ground wire connected, and then we need to run the red wire back into the engine compartment. Now, you can see in the picture, and you'll see in your truck, there are a lot of wiring harnesses running in this area. And if you want to cut those open and embed the wire in the harness and make it almost totally invisible, you can certainly do that. What I ended up doing was just running the wire along the rubber molding that goes along the front of the firewall. And you can see here that I just pulled that back and stuffed the wire in. And coming further down, you can see where I pulled it out of the rubber grommet in order to get it in the proper position to insert into the engine compartment. There's a big rubber grommet where the major wiring harnesses goes in. And certainly you could unwrap all that and open it up and try and insert the wire down the middle, but it's not easy to do. What I did on mine was to just make a slit in that rubber grommet and then thread the wire into the passenger compartment. Now, it doesn't always come through cleanly. You may have to search around for the red wire on the inside, grab it with a hook and pull it out. And when you do, you want to make sure that you route it above any area where it could potentially bind with the throttle, with the accelerator pedal or the brakes or clutch or whatever. But it's pretty easy to route the wire down. Now we're going to move to the inside of the car. We've pulled the red wire through and kind of threaded it through to the center portion of the dash. And what we want to do now is open the ashtray holder on the very bottom, just above the transmission tunnel, and we want to go ahead and pull that out. There are two screws on either side of that. They're kind of hard to get at, but if you remove those two screws, that module will drop down and you can remove the entire ashtray cigarette lighter module. Once we've done that, disconnect the wire from the center cigarette lighter outlet, and you'll note that there are three different cigarette lighter outlets on the dash next to each other there. All three of those are direct connect to the battery, so they are not modulated by turning the ignition switch on and off. They are full-time power. What I ended up doing with mine was connecting into a full-time power. And if you do that, you need to be sure that if you're going to leave the car untouched for 4 or 5 days or so, that the switch is off. If you leave it on and for an extended period of time, it can start to drain the battery. You can find a switch, ignition switch modulated power line, and probably the best way to do that would be to go back to the fuse panel behind the passenger side seat and pull it out of that area and run it up under the center console. I'm sure I'm going to go back and do that on mine over time, but it's not a big problem to have it on full time. Here's a picture of the rocker switch that we're going to use, and it actually will plug into a cigarette lighter outlet. And I use the center one that kind of folds down when you open the center console. We are going to pretty much destroy that cigarette lighter socket. And you can see in the picture that the back half of that has been cut off with a hacksaw or a bench grinder. And basically we need just the metal part sticking through. It's a little tricky pulling that cigarette lighter out. And since we're going to destroy it anyway, don't feel bad about using a small screwdriver to kind of bend out all of the tabs on the inside that hold it in place and pull it out. Once we've gotten that out, the switch will fit into the cigarette lighter outlet, um, and it is a lighted rocker switch. And here's a picture of the back side where that comes through the little swing down part of the center dash. It actually fits tight enough that you don't need to really secure it in place, but I always feel better using a little hot glue just to make sure that the switch doesn't rotate or rattle or come loose over time. The wiring is just using the splice connectors that are provided with the kit and splice it into the power and ground for the cigarette lighter, and that will give you all the power you need and you get a good solid ground. And then the third terminal on the rocker switch will go to the red wire that we pulled in from under the dash. It's fairly easy to wire it up. It'll be obvious. You do want to make sure that if I would just leave the socket in place on the power and ground to the cigarette lighter, that we're going to use. But if you decide to cut those two wires, you got to cut them one at a time. If you cut them together, you'll blow a fuse. Anyway, that completes the installation, and you'll see that the switch comes on blue when you have the heater core turned off, have the core regulator turned off, and the blue means AC. And then when you switch that off, it's back to normal functioning mode. Water will circulate through the heater core, and the car will run just as it did before. But when that blue light is on, you're going to get much better AC performance. On my vehicle, and I'm not going to commit to this, but on my vehicle, just measuring the airflow internal, I saw 7 degrees difference between running with the heater core on and the heater core off. And hopefully you'll see those same sorts of results, and it will definitely improve the AC efficiency. We're going to finish up this video by taking a look at a plenum box pulled out of an SSR and give you a little idea of what the problems are with the system. First of all, the SSR runs a big engine. It runs hot. It'll run 210 to 200 degrees, and all of that water is being circulated through the heater core. And this is a constant circulation of 200+ degree water. The system has a blend door, and the motor will sit here, and this is what moves the blend door. So when we want heat, that door is moved up in this direction, and now all the air is flowing through the AC evaporator core, which is turned off for heat, and the air is diverted through the heater core and will flow along this path and provide the heat for the system. We shut off heat by turning that blend door to where it's up against the heater core. It is now blocking airflow through the core. And now your flow path will be up in this direction, and air is diverted away from the heater core. The SSR has two problems. Number one, the heater core has a metal top on it, and this is constantly radiating heat. And the metal is a very good conductor of heat, and you get a significant amount of radiation out of this system. Most vehicles will either put a plastic cover over this or actually make the heater core plastic. And while that doesn't stop the heat, it is much less efficient at transfer of heat than the metal SSR parts. The other problem is the airflow and turbulence in the airflow. Now, even when we've got this in AC mode and we've shut this off, we've still got air, circulating past the heater core, but there is still some turbulence in this box around the back of the heater core. And so even though no air is flowing directly through the heater core, we are still getting a significant amount of heat being transferred in the airflow, just in the turbulence on the back end of this box. And on the SSR, this box is truncated. It's a very short box, and you get a lot of radiant heat getting into the airflow. Now, what we are doing with the core regulator kit is we are cutting off the flow of air through this heater core. So we're basically making this a neutral element. We are eliminating any radiation from the top of this core and any radiation or mixing of hot air from turbulence on the back side of the core. In addition to which, the plastic will heat up over time. So it's not just radiant heat from here. This whole top of the system, when you reach steady state operation, is going to be very warm, and airflow will go past it. So we are injecting heat into the AC system. That forces our AC evaporator core and the compressor that drives it to work harder, because now not only is it trying to cool you, it's also having to eliminate this excessive heat under the dash. Once we cut this out, we get much better efficiency of the AC system. You will cycle the AC compressor at a lower frequency, less strain on the engine, less gas used, more efficiency. It's actually somewhat of a green solution because we are saving gas, improving gas mileage. So that's some additional information on the SSR. What I've pointed out here is true of virtually all vehicles, and while the SSR may be a worst case of the variables, all vehicles have this problem, and we'll see significant improvement in AC performance by taking the heater core out of the system when running in AC mode.